All right, and we are live. All right.
All right, guys.
Hi all.
Hi, everyone.
All right, let me just introduce quickly. Welcome to Google Developers Group. Pick and choose on Google Cloud. Firstly, let me just a few words about Google Developers Group. It's a community of developers who are interested in Google Developers products and platforms. Today, we have Harris here who will be talking about pick and choose on Google Cloud. Harris, thank you very much, and handing over to you.
Thank you so much, Peter. It's a wonderful experience to actually join in. So my name's Haris. I'm the CTO at Waterman, which is an online marketplace based out of the UAE. And I'm also a cloud expert with Google Cloud. I've been for over 2 years now. Today, we're essentially going to focus on talking about some fundamental problems in choosing what technology has to offer on Google Cloud. In order to do that, we first have to understand there's a very common debate in terms of architectures and services, because a good part about Google Cloud is that it has so many services. Basically, it has services for everybody. But that, along with that, there is a problem that arises, which is which one to choose at what point. Us as, engineers, a common problem that we face or a common phenomenon that we go through is the perfection loop. We try to build things better and better and better every time. And as a result of that, one of the common challenges that we usually face is that we try to overcomplicate things sometimes. So like the quote says, don't use a cannon to kill a fly. In that similar manner, we need to understand as engineers that we have to find the most optimum solution to our certain problems, keeping in mind different variables that could be sometimes the number of users that we're looking to support and the number of the kind of traffic that we're expecting and other aspects as well. So given that, essentially it depends, on on a lot of factors in terms of where or what should your application be hosted upon. And even sometimes it also depends on the kind of team that is managing and developing it. In that aspect, a good part about Google Cloud is segregated into three sections. On the left, you have infrastructure as a service for people who want more control over their services. Then in the center, we have platform as a services, which is a combination of serverless as well as infrastructure as a server services that include the Kubernetes engine and the app engine. And finally, you have completely serverless tools such as Cloud Functions and Cloud Run. We'll be talking about all of these services in a lot more detail and what is a tailor-made use case for each of these services. And my objective today is to actually help you choose between all of these services that the Google Cloud has to offer for you to be able to deploy your services better. So firstly, you have the compute engine. This is a bare bones server that Google Cloud has to offer, which has different pre-built images such as Debian, CentOS, Ubuntu, etc., already available to you. Your CPUs can be 416 CPUs to max, 12 terabytes of RAM, and you have a lot of special purpose machines as well. So these are essentially virtual machines that you have complete access to. You can configure and use them as per use case, but only if it is required to do so. Then it is categorized in two categories. One are general purpose for essentially applications that are very general purpose. So there's a lot of commonalities between applications today. So if there are not no any special purposes, I think general purpose is the way to go. For example, and the other ones are work optimized ones. So for example, if your applications are more CPU heavy, then you have those machines. If they are more memory heavy, you have according to that. And if there are any other options, so there are some GPU level machines if you basically want to run some complex algorithms on. So those are also available within the compute engine. Moving on, the good thing about compute engine is that you have flexible machines, and you can configure them as you go. And you can also have on-demand machines with a configuration of minimum 1 core to approximately 96 CPU cores, and extended memory that can basically range from up to 52 GB. So that depends on the kind of application that you're running, but all of those options would be available on your machines on Google Cloud and the compute engine. Moving on, the second engine, which is a part of the component that is platform as a service, is Kubernetes. And for that, you have the Google Kubernetes engine. In this, your application is going to be completely containerized, which has sort of virtualizes your OS. These are extremely portable and lightweight containers. So the best part about these is scaling is quite easy to do with that. You can basically set up, your threshold levels for a container to scale up and even scale down at certain events that can be triggered by your application. So you have that portability along with the scalability that the Kubernetes engine does. So Google offers this as a service as well. Finally, you have serverless technologies that include Cloud Function. The good part about serverless technology is these are mostly used for applications that that you want to develop very fast. The difficult part about serverless applications is that they're fairly costly when you have a very high scalability level. So moving to serverless technologies, you essentially have two USPs. Number one, your auto scaling is very well managed. The other thing is you don't require to manage your infrastructure at all. Google Cloud has three available services for serverless applications. Number one is Cloud Run, in which you can run containers on a fully managed environment. Then you have the App Engine, that maintains source-based web applications on a fully managed environment. Finally, you have Cloud Functions, which are event-driven, and you can offer them as a function as a service. So you can define the smallest amount of functionality within a Cloud Function. The tricky bit with that is, because these services actually charge you transactionally, so the cost may be a factor. But for applications that you want to build fast, or if you want to get a MVP out of the way quickly, Cloud Functions and serverless technologies are usually the best way to go forward. Finally, you have Cloud Run as well. Cloud Run offers you to bring containers to production within seconds. These are natively serverless, so you can basically scale them down to zero. If your consumption is now very high, one experience where you want it is, if you're running a GKE cluster, it can be consistent with your APIs and tooling to, portable native without even having a vendor log within. So those are some use cases for Cloud Run. Finally, what we understand from the services that we have, there are some factors that you need to consider before you decide on what service to use. First one is what level of abstraction you need. The second one is what is your use case, essentially. So are you building an application that is supposed to serve a million users, or are you just building a special case application that is only going to be available to 100 users? The other thing that you also need to consider, do you need it to be portable with open source, or are you using some sort of application that is already developed and is not open source? So you need to consider also that. Finally, you want to understand what the skill sets of your teams are. So in the growing age of technology, we understand that some regions have massively available skill sets of some domains. For example, in region A, you might have a lot of Python experts, but in region B, it would be more Java experts as compared to Python. So you would want to understand what is the background of each of those to make that decision. Uh, and what the last one is, what kind of billing model do you prefer? Do you prefer a billing model where you are charged upon the hours of a machine being up, or do you prefer being transaction because you already know that you're going to make a limited amount of transactions over a certain period of time? Once you've considered this, I created a cheat sheet of when to use what service. So if you want to map out a use case for each one of them, so we'll move on from Cloud Functions over to the Compute Engine. So Cloud Functions or Cloud Run are usually services that help you spin up an instance and set up your backend in a very short period of time. And these, although are transactional in model, but these are best suited for developing your MVPs or small scale applications that have a smaller business objective, usually to go to market and, and or to run POCs as well. So those are your best option. If you are running a mid-size application that has a significant number of users, but you do not have a lot of managerial resources in terms of managing your infrastructure, Kubernetes is a very good option to consider. And finally, if you want complete control of your application, you want to manage the infrastructure and you have the resources to manage your infrastructure, and let's say your scale of your application is going to go extremely high, and you need, from a compliance point of view, you need complete control, Compute Engine may be a very good option for you to choose. So that's it from my side. That's all I had for this talk. For Q&A, I think we can open the floor up for Q&A. If you have any questions, please type them in the comments, I believe.
All right. Thanks, Harris. So the time as we're waiting for our attendees to raise the questions, if you don't mind, to ask you my questions.
Sure.
Based on your experience, as we know, usually when we start the requirement, when we start the project and how it's developed, how based on your experience, with which one would you start when we have we need to figure out basically what will be the workload, what will be the requirements, what will be
so I think
starting product?
I think that's actually a very good question in terms of understanding tech. So I would want to take a step back and I would want to understand one thing. So a lot of people misconceive this is that tech is usually a facilitator to business. It's not the business in itself. So everything needs to be aligned with your business objectives. And in most cases, you're very short on time, right? For an application that you're starting from scratch. So I think if you go with something like, let's say, Firebase or Cloud Functions, or even Cloud Run for that matter, to start up an application, that is a very good option. And as soon as you get to a product market fit phase, then you can start building with something that is more platform of a service, or even choose to go infrastructure. That also depends on your team size as well, right? If you have a lot of resources available, which is usually not the case, then I think you can also go with infrastructure as a service. But because you want to use resources efficiently, so it's usually better to go from the serverless route towards the platform as a service route.
Thank you. That was my follow-up question. I wanted to ask you if you have any, I would say, good hints how to move away from one to another, because as you know, usually when we choose one solution, then usually we stick with it because keep building on top of that. At some point, it's hard to move away to more scalable ones.
So the thing with working with a lot of startups has been in the beginning of the phase, you want to build something that is hacky, that has problems, obviously a lot of technical debt. But at that point, your business objective is usually going to be, deliver something, put something out in the market that works. But I think as a engineer or a senior engineer, it is your job to actually tell them dude, this was designed for, let's say, 100 users. We're going to 10,000 now. there is going to be a certain restructuring and refactoring of the code, or even restructuring of the infrastructure. That depends. Which is then again a chicken and egg problem, which most lead engineers face. But I think, I think there's enough awareness now in today's day and age that people understand these things better than they used to. So, you can be a very good advocate of these services, but you need to explain it to your business users, right?
Especially that one of the main questions will be how much it will cost, right?
Yes, yes. So the thing about transaction is they usually charge you, let's say per 10,000 transactions, you get charged in X dollars of amount to a certain, criteria that works. But after a certain point of when your users actually grow and you graduate off that, that cost is going to be significantly higher as compared to when you use infrastructure as a service, right? So at that point, you have to change because it won't make economic sense. So you have to care about sustainability as well. So you have to switch at the right time, which is super critical as well. So when I think you also need to be aware of the future or how the progress is being made in terms of growth, etc. So make the right decision at the right time of migrating from a serverless to a platform as a service or infrastructure as a service, whichever suits your needs better. But yeah.
All right, thank you. So we have a question from Arkadiusz.
Which of the options you will consider as proper for small data science team? We do ML on a VM. However, it's often case for us to have huge latency between code executions. So for ML, there's a lot of tools on the Google Cloud specifically designed for ML. So maybe you should do a special purpose machine on a VM that works for your system better. Or, I don't know the extension of that you are using in terms of code. Are you using something like TensorFlow or some other algorithm, etc.? So it primarily depends on that. But I think if you are choosing to use a VM, you should check out the special purpose VMs that are optimized as per the requirement that you want to serve. So sometimes your applications may be CPU heavy or sometimes RAM heavy. That depends. So you will have to choose according to that based on Google Cloud. But if you give more context in terms of what kind of application you're running, I can probably give you better advice. Okay, that's one question we have. Is there another one?
Thank you, Arkadiusz, for the question. As Harry said, if you're willing to, please provide some more details. I assume that you're using BigQuery or Vertex, so this needs to be also considered. Yes, in the meantime, as we give time to Arkadiusz to give some more context, one more question. Usually, the tough discussions when there's some significant overcharge in services. Like, do you think is like any smart way how we can manage that? I know, we can.
Sorry, can you repeat that?
Oh, sorry. Yeah, I hear
sorry,
you.
Can you repeat that?
Yeah, I just wanted to ask you because usually the conversations are starting when when there's a huge bill coming in. The business is growing, and we didn't switch the process to the more efficient solution. Do you have any best practice that you can share with us? Of course, we can quote, but this would interrupt with the business. So, is there any other way how we can put an eye on the cost?
So there's a subjective question, right? So but those scenarios are very real and they do happen. I have to acknowledge that. But keeping that in mind, right? Because your application is going to be built upon different components, right? And sometimes just migrating or redoing the whole thing just doesn't make sense. So I think the best way to solve such a problem is like you break it down into smaller components. Let's say you have different features, or these components could be based upon modules or features, or sometimes as different services as well. So you want to start on building the new features or new components onto different engines. And right now, I think it's a lot more easier to do this with the likes of the AI tools that you do have available. For example, you have Bard, you have other platforms. So you can start breaking those components out, and in every sprints you can just push out containers for those, and manage that along with your day in day out development. Because eventually you will have to do this, and as tough as it may sound, there's no other way around that, right? Otherwise, the biggest hit, you can still go on with serverless to infinite users, but the thing is the cost would be so significantly high that it wouldn't make economic sense. So at least either what you could also do is see the most used components within your application, migrate them first, and later on migrate other components, and hopefully that becomes easier for you. But generally devise a strategy around it, right? I hope that answers your question.
Yes, it's the question. Just wanted to hear what is your experience on that. Usually we learn the hard way, so we can help others
in most cases
not make the same mistakes.
Yeah. So I think those mistakes are very common globally, not just in Poland or in the UAE or anywhere else. It's just our normal scenario because everybody's pushing to being very optimistic or being very perfect, which is usually not the case. So things do break, things do crash. Keeping that in mind, it's okay if your application fails sometimes. Just have no fear in terms of if things break. The biggest platforms or the biggest companies have downtime too, so it's okay.
Okay, thank you. It was really well summarized. I don't see we have any more questions, so I think we can close. Harris, one more time, thank you very much for your time and for this presentation and sharing with your experience of the story. Okay, Arkadiusz just made that in the last moment. Sorry, we need to hold on for a second.
Yeah.
Thanks, Arkadiusz.
So thank you, sorry for your resource usage, not a problem. But when members are working in parallel, executing Jupyter Notebook cells, we experience hiccups. So I think what your challenge here is because you're managing workloads on a singular instance. That is one of the biggest challenges that is very commonly faced. So I think working with special purpose machines should solve that, or maybe you could also containerize this and break it down into multiple instances. That should be able to help you if you haven't already tried that.
Thanks, Arkadiusz. I'm glad I'm glad that you made it before we close it. Of course, if you have any further questions, you can just drop us an email. I think we will be picking some topics on future events. Thanks, Arkadiusz.
Okay. Thank you. Thank you.
So,
thank you, guys.
Coming back. Thanks, Harris.
Thank you.
Hope you join us at some future events as well. Thanks.
Hopefully, sure. Thank you.